So in this video, we're going to continue with the mean value theorem, lesson 4.2. We just have a few examples we're going to go over of how the mean value theorem is used. Here we have a word problem. It says that Calvin runs a 100-yard dash in 20 seconds. S sub t is the function that gives his position from the start of the race. We're going to assume that S sub t follows the standards of the mean value theorem. So we're going to assume it is continuous and differentiable. Show that Calvin must have been going a speed of 5 yards per second at some point during the 20-second race. So let's think about what we know. Let's think about the slope from the beginning of the race, 0, to the end of the race, 20 seconds. So we know that the slope between 20 and 0 is we'll call it S of 20 minus S of 0. Now that's just the position you're at 0 versus your position you're at 20. Well, they told us the position we're at is the start of the race. We haven't run anything, so it's 0. And the position we're at 20 is 100 yards because it's a 100-yard dash. So if you look, the slope is 100 minus 0 over 20 minus 0, which is 100 over 20, which is 5 yards per second. So we can say that since the slope from the beginning of the race to the end of the race is 5, by the mean value theorem, there must be some point C from 0 to 20 where he was going 5 yards per second. So it just so happens the speed we're looking for is the slope between them. And if it's a continuous differentiable function on that interval, whatever the slope is between those 2 points, there must be a C somewhere in there that matches that same slope, that same rate. And so in this particular case, it was 5. So it happens to be, we are guaranteed by the mean value theorem that he was going that instantaneous rate of speed of 5 somewhere at some C. Okay. Kind of a silly result in a way, but it just kind of shows that how you go about kind of proving that there must have been a point somewhere that he was going 5 yards per second. An instantaneous, remember that's an instantaneous rate because it's the derivative. We know that somewhere along the line, the first derivative at some C would equal 5. So he had some instantaneous rate, some spot in the race that he was going exactly 5 yards per second. They didn't ask us to find where that happened. We don't know where that happened because we would need more information about the function, which we don't have. So there you go. Let's do one more. So here it says, determine all the numbers C which satisfy the conclusions of the mean value theorem for the following function on the interval from -1 to 2. So the first thing we do is we plug in those endpoints. Remember, that's an interval. Those are both x1 to x2. We started at some x value. We ended at a different x value. We're going to plug those in. We get -1 plus 2 plus 1, which is 2. And then we're going to plug in 2, which is 8 plus 8 minus 2, which is 14. Now let's find the slope between the first x value and the second x value if we were to connect a line between those two. So the slope between, on that interval from -1 to 2, is f of 2 minus f of negative 1 over 2 minus negative 1. And we already found those values, which is really great. So that's going to be 14 minus 2 over 2 plus 1, which is 12 divided by 3, or 4. So what do we know? Well, what we know is there is a c, so we're going to find c, such that the first derivative of the function at c must equal 4. So we should be able to find some c where the first derivative of c has to equal 4. So let's take the first derivative of our function. So that would be 3x squared plus 4x minus 1. Let's make those c's, and let's look where would that equal 4. Okay, so there's some c that makes that first derivative equal to 4. This is our first derivative. So we're looking at where does it equal 4. Well, it's just a matter of solving now. Move the 4 over. You get 3c squared plus 4c minus 5 equals 0. You can slide and divide if possible. This is not a factorable quantity, so we're going to jump to the quadratic formula. So it's negative 4 plus or minus the square root of b squared. Minus 4 times a times c ends up being positive 60. A is 3, 2 a's then would be 6. Now let's go ahead and solve for that. Now remember, our c must be in the interval. So we have to check those numbers. Which one of those numbers is in negative 1, 2? They both might be in the interval from negative 1 to 2. I don't know yet. If we do negative 4 plus the square root of 76 over 6, let me tell you what we get. That's approximately 0.78. That is in the interval, so we definitely know that that's a c that works. Now let's see if we have two c's. We're guaranteed at least one. Let's see if the other one works. So let's try negative 4 minus the square root of 76 over 6. You get, it's approximately negative 2.12, which is not in the interval, so that one we don't want. So the only c that we want is the positive one. So remember, we're just guaranteed one that will work in the interval. Once you get the answers, you always got to check, are they within the x values that we're looking at? In this particular case, we need x values between negative 1 and positive 2. And so the only one that works is this one. You could reduce that square root a little bit, but because it is divisible by 4. But that's good the way it is. And those are some examples of the mean value theorem. Here is your assignment. I think that page might be wrong, but just find 4.2, and you're just doing the odds 1 to 7 and 11 to 15.